Today, let's talk about application of definite integral, which is called volume by revolving. Okay, or rotating, if you like to call it rotating. So what you are going to do, you have three types to find the volume by rotating. These three types, first of all, you have to think about revolving about x-axis, or like this one, you revolve this curve about x-axis, right? So you will have this shape, okay? Or about y-axis, when you revolve this red one, you will have this shape, right? So this is the two type of revolving. Sometimes no need to revolve about x or y. You revolve about a line parallel to x-axis. Okay. So this will be horizontal line. Horizontal line. Or also a line parallel to y-axis. So this one will be a vertical line. A vertical line. Okay. So instead of revolving about x-axis, you may have a line like this one parallel to x-axis. So the line of this one is y equal to constant, right? So when you're revolving about this one, you have the shape, but the radius will be up to this line, okay? When you're revolving about a line parallel to y-axis like that, so this is a vertical line. The vertical line equation is x equal to constant, right? So when you're revolving about here, so you will have the radius up to this line, okay? Fine, so we know revolving or rotating, we are rotating the shape given by the curve y equal to f of x about x-axis or about y-axis or parallel line to x-axis or y-axis. Okay. If you would like to have the volume generated by the function y equal to f of x when I'm rotating about x, so any point rotate about x-axis will make a circle. This circle with a radius equal to what? Yeah, it is a vertical. The radius is vertical, so the radius of each circle will equal to y. Fine. So the area of this circle is by r square, so it will be by y square. That's fine. So if I accumulate this slice, I will get the whole volume. So the volume will be the integration. If I'm start from A and to B, so the integration from A to B for, yes, for by, the radius here is vertical, so it will be y square, and I am accumulating the slice, so the slice will be cut through x. So small slice will have dx thickness, right? So this is the volume when you are rotating the curve y equal to f of x about x-axis. What about the volume if you rotate this one into y-axis? Okay. So in this case, you have each point in this curve has a circle with radius equal to what? The radius is horizontal, So the radius of the circle here is x. And the area of this each circle is pi x squared. Now the volume will be what? The integration. Yes, let us say start from C into D, right? So C, D. The area of each circle is pi x squared, and you slicing this cylindrical shape into pieces. Each piece has a small slice in the direction of y, so each one will be dy. Very good. But remember, yes, in both you have y as a function of x. So in this case, you have changed x as a function of y. So in this case, we should have x as a function of y. How to get this one? Yes, say y equal to sine x. So x will be what? Yes, the inverse function of x. Let's have another example. If you have y equal to root square x, so x will be y squared. This is how to find x as a function of y, if it is possible, right? To integrate with respect to y in this case, right? Okay, here I have no problem because I am already having the curve as a y as a function of x. Okay, let's have an example just to check this one. Okay. The question is, find the volume generated by revolving what? Yes, the function y or the curve y equal to half x squared. I have to mention it is rotating about y-axis or x-axis. I will ask you for both. About x-axis and what is the lower bound and upper bound from 0 for x till x equal to 2. Also, the volume when you rotate about y-axis and okay. Now, some people thinking about graphing the curve. No need to graph the curve. As I told you, section A, you are rotating about x-axis. So when you're rotating about x-axis, so your radius will be y, right? Because you are rotating each point like this. So the radius will be y. The area of this circle will be by y squared. And you slice this one up to x, and the thickness of each slice is dx. So this will be the volume, right? Okay. So the volume equal to what? In this case, equal to the integration by y squared dx from 0 to 2. Are you ready with your calculator? Y is what? Y is half x squared dx. You can do this one straightforward by your calculator, or you take this one outside and you integrating x squared dx. So that the integration of x squared is x to the power 3 over 3. Don't miss to write the lower and upper bound. Substitute by 2 first, so you have 8, or just make it 2 to the power 3 over 3. When you substitute by 0, you have already 0. 2 to the power 3 is 8. So you have 8 by over, yes, over 6 unit cube, because I'm dealing with the volume. As simple as that. Let's go for the volume in the case of B. So when you go for B, your volume will equal to what? Yes, the integration from 0 to 1 y. Yes, when I'm revolving about y-axis, so the radius will be horizontal, so it will be x. So I need to have x as a function of y, right? Okay, so by, sorry, x squared, and the slice will be dy in this case. So integration from 0 to 1 by, what about x squared? X squared from this one, x squared will be 2y, right? So I have 2y dy. Very simple integration. So this one will be 2 by outside, integration from 0 to 1 for y dy, which is 2 by y squared over 2 from 0 to 1. When I substitute by 1, I have half. So I end up with by unit cube. Okay. Now, let's go for another method of finding the volume by revolving. Okay. This method, we call it what? This method, we call it disk method. So this is, we call it disk method. So the disk method, you use it when you have only one curve rotating about x-axis or y-axis. So what is the other method? The other method, we call it shower method. The shower method. In this case, we have two curves, right? Also, the shower method, we have it for two cases. Revolving about x-axis or revolving about y-axis. Okay. In this case, for the shower method, you have two curves. Okay. No need to be intersect, right? Say you have one curve like that one. And we have another curve like this one. Okay, make it different. Okay. And we would like to have the area between these two and this shaded area, we would like it to rotate it about the x-axis. Okay. Also, if we have another two curve, but we are going to rotate about y-axis. Okay, say you have this curve and you have this curve, right? And you have a shaded area, say this one, and you would like to rotate this shaded area about y-axis. Okay, so it is exactly like what? Like having the volume of the upper curve minus, yes, minus the volume of the inside one. And when you cut these two volume, you will have the volume generated by the shaded area, right? So in this case, the volume will equal to, let's call this one y2, and we call this one y1. So the volume, and you would like to have from A to x equal to B. So I have the volume of the upper one, which is y2 squared, minus the volume of the lower one. Okay. If you go for y, you will do the same. You will have the volume generated by the outer one, and you have the volume by the insider one. Okay. And you cut these two to get the volume equal to what? Equal to, as we said, the integration, let's see, y from C to D by, yes, you should have the function, outside function, it is x as a function of y. So call it x1. And the inside one, we call it x2 as a function of y also. So we have the volume of the outside one minus the volume of the inside one. And this will be easy. So it is exactly like two volume subtracted from each other to give you the volume coming between the two curves by rotating the area between the two curves. Let's have an example for this. Okay. Calculate the volume of the solid generated by or obtained by rotating yes, I have the region this region bounded by the parabola y equal to x squared and the square function y equal to root square root function y root square x. Yes, you have to mention you are going to rotate or revolving about what? Yes, I'm asking you to have it about x-axis. Okay. Now, once I have two curves, I'm thinking about what? Yes, volume by revolving and the washer method. Okay, so the solution, even if you don't know the graph of this function, right, and you swap this one, this is the volume in this case because I'm going to revolve, sorry, this is the case because I'm going to revolve about x-axis. So even if I don't know which one is the upper one, which one is the lower one, the difference between you and your friend will be only the sign. Okay. So let's do it and see. We will have positive or negative. Okay. It must be positive. If we have a negative, it means we swap the upper bound by the lower bound, right? So because I'm going to rotate about x-axis, so the volume equal to the integration from what? I don't know. In general, I know from A to B by the first one minus by the second one dx. This is a formula. So I need what is A? What is B? A and B are the intersection point of the two curves, right? A and B, if it is not given, so I have to get A and B are the intersection point of the two curves. How to find the intersection point? Simply, the intersection point is just when you have intersection point. Let's see this, any curve like that, any line like this. This is the intersection point. So this point lies in the line and lies in the curve. So at the intersection point, x here is the same and y is the same for each curve, right? So this is why I'm saying how to find the intersection point. Okay, so you have y, which is equal to x squared, will be the same as y equal to the root square x, right? How to solve this one? Square both sides, so you have x to the power 4 equal to x. Move this one to the other side, so you have x to the power 4 minus x equal to 0. Now take x as a common factor. You have x cubed minus 1 equal to 0. Now, if you have two things multiplied and you have equal to 0, so each one of this might be 0. So x could be 0 and x could be 1. So I find A and B. Now, the volume will equal to what? The volume equal to the integration from 0 to 1 by, yes, y1 square is, or y2, doesn't matter which one is bigger, okay? As far as I know, root square x will be the upper one, and the other parabola will be down, okay? So I missed to square this one. This is the volume from the upper one minus the volume of the lower one. All of this one will be integrated with respect to x from 0 to 1. Can you use your calculator and give me the result of this one? Or you can write a MATLAB command to find it. Or you can do it by hand, right? So the volume will equal to, I will take by outside from 0 to 1, root square x square will be x minus x square will be x to the power 4 dx. So I have by, the integration of x is x squared over 2, the integration of x to the power 4 is x to the power 5 over 5. Now substituting by the upper bound, I have 1 over 2 minus 1 over 5. When I substitute by 0, I have 0. Half, the common factor, the denominator for this one is 10. This is 5 minus 2. So I have 3 over 10, which is exactly 0.3 pi, and the volume is unit cubed. Okay. This is how to find the volume using the washer method. Okay. Sometimes the disk method is not working. The washer method is not working. So we have the last method. We call it volume by cylindrical shell. First of all, I'll give you this example before we skip to the next one, just to show you why we're having the other type of finding the volume by revolving. This is the example here. Find the volume of the solid obtained by revolving or by rotating the region okay, a shaded region in the figure in the following figure. Okay, here is the figure. Here is the curve. This curve is given by, this is a shaded area he's asking you to, and the function is y equal to x squared minus x cubed, right? And as I told you, you have to think about rotating about what? Yes, about, in this case, about y-axis. Okay. So, why I'm telling you about y-axis? You have no problem if you rotate about x-axis. This is the disk method. Okay. So, I will give you this one into two cases. Case A, this is from 0 to 1 about x-axis, about y-axis. As far as I see, you have no problem with the x-axis. Let us see. I just remind you, when we have a curve and we rotate it about the x-axis, the volume was what? Yeah, when I'm rotating about x-axis, like this case, we have the volume as the integration from a to b by the curve square dx, right? This is what we are going to do in section A in this problem. So section A, the volume in this section, because in this section asking you about the volume about x-axis. So the volume will equal to the integration from 0 to 1 straightforward, and by y squared dx. Okay, so it will equal to, by outside, the integration from 0 to 1, y is what? Y is x squared minus x cubed, here is a square, dx. If you have your calculator, you can do this one straightforward. If not, you can do it by hand as follows. By the integration of it, yes, first expand this one. So the square of x squared is x to the power 4 minus 2, the first one, x squared times x cubed, x to the power 5, and I have minus 2, sorry, x to the power 5, plus x cubed squared, it will be x to the power 6 dx. This is how to expand this one. If you have x plus y squared, this will be x squared plus 2 xy plus y squared. If you have minus here, you should have minus in the midterm here. Okay. Now, let's integrate. So this one will be equal to pi. The integration of x to the power 4 is x to the power 5 over 5 minus 2 x to the power 6 over 6. This is the integration of x to the power 5 plus x to the power 7 over 7, the integration of x to the power 6 from 0 to 1. Now, what I should have, by 1 over 5 minus 2 over 6 plus 1 over 7. That's it. Everything left is 0. You can find this one. This is unit cube. Okay. This is a volume when I'm rotating about the x-axis, right? So yes, this shape, when you're rotating about the x-axis, it will be like that. Okay. Fine. Let's go to rotate about the y-axis. Okay. If you would like to rotate about y-axis, it means what? It means this point stay as it is, right? And I cannot have it nicely. Okay. This is really difficult for me to have it. Okay. So, as I show you in the beginning of the lecture, this guy who's doing, let's go for this shape. Okay. Yes, when you are doing like that, okay, this is a curve. It will be between two curves, right? So you have a hole in between. Okay. So you just imagine how to do this one when you're rotating about y-axis, right? This is section B. I finished section A. Okay. Yes, if you can say this is the integration, as I remember, from C to D by, yes, x squared dy. Can you get x as a function of y? You have y equal to x squared minus x cubed. Can you find x as a function of y? This is the question. No. For me, no. I cannot find x as a function of y. This is why we are going to have the last method is volume by cylindrical shape or cylindrical shell, if you call it. Okay. Okay. What is the case here? Yes, you get the here. You will get a washer. They call it washer cannot work, and the disk cannot work in this case because we cannot find x as a function of y. Fine. So when you're rotating this shape, you will have the surface area is as the circumferences for this circle moved around here with the radius equal to what? Yes, the radius of this circle will be x because it is horizontal. So you have the circumferences of this circle is 2 pi x. Fine. And you slice this one in this shell, you slice it up to x, okay? So the thickness for each one will be dx. Okay? And the height of this thickness will be yes, y. Okay? So if you accumulate this one up to x because you are rotating about y-axis, so from 0 to 1, this will be the volume in this case. Okay, let's do it. Yes, so this one will be equal to what? 2 pi outside, integration from 0 to 1. You have x, y is x squared minus x cubed dx. How to integrate this one? Multiply x first. So you have 2 pi, the integration from 0 to 1, x times x squared is x cubed minus x to the power 4 dx. If you have your calculator, you can do it, but I prefer you can do it by hand. This is 2 pi. The integration of x cubed is x to the power 4 over 4 minus x to the power 5 over 5. Okay, from 0 to 1. If you substitute by 1, you have 1 over 4 minus 1 over 5, and you substitute by 0, you have 0. This will be unit cube. Okay, now I finish my turn. Let us summarize what we have done. We have volume by cylindrical shell. We have volume by washer. Okay. And we have volume by disk. Here you have one curve. Okay. Here you have two curves. Here you may have one or two here in this one, but your problem, you stuck to have x as a function of y or y is y. So when we cannot use this one or that one, we have to go for volume by cylindrical shape. What is the three formula for this one? Okay. Number one, as I said, you have to mention you are rotating about x-axis or y-axis. Or about y-axis. So the volume will be, yes, from A to B, okay, for pi, and the radius will be vertically, so it will be y squared. This is the area of the circle, and you accumulate this one as a slicing into x, so you have it dx. For the other one, in this case, from C to D by, you get x as a function of y as an inverse function, and you square it, and the slice will be horizontally. So this is the formula when you are using the disk, when you are rotating about x-axis. What about, sorry, I get it by mistake. This is number 2, sorry. The washer, also, I have to mention about x-axis or about y-axis. As I said, about x-axis, you have two curves in this case, so it is the volume will be exactly the volume from the first one, call it y1 or y2, minus the volume of the first one, and both of them having slice thickness dx. For the other one, if you are rotating about y-axis, so you integrate from C to D, the volume of the outer one, so in this case x as a function of y, minus the volume from the inside one, and the thickness of the slice will be, sorry, d1. Okay, fine. Okay, in this washer, you have to be very careful in this case. In this case, you have the circumferences of each circle. So you're rotating about the y-axis, so the radius will be x, and the circumferences will be 2 pi x. And you multiply by the height, and the slice thickness will be dx. If you are rotating about x-axis, x will be replaced by y, and y as a function of x will be replaced as x as a function of y, and the thickness will be dy. That's all for today. And if you have any question, please ask.